Hello everyone and welcome to the channel. So this particular video is a part of a series which have been started on this particular channel since last 4 weeks. Okay, so this is the fifth week in which this video is being published, and this series is called as Monday MCQs. So what I have done is I have started I have started posting questions based upon a specific topic on the channel. So if you are not aware about that, I'm just here to tell you that on every Monday you are going to get some list of questions, 10 to 15 questions on a particular topic in the community tab of the channel. Okay, so you will get notified to it if you will subscribe to the channel, right? So do subscribe to the channel to get notified, and just check out the question sheet. You should solve that out in the next 1 or 2 days, and within the 2-3 days I'll be posting solutions of that. Okay, so this is going to be the solution of the last Monday, which the last Monday MCQ, which was on the topic of quantum chemistry. So the solutions are in the next part of the video. So every week this has been done like that only. We have covered few topics. We have covered, this is the fifth topic, right? So if you have any suggestion regarding the next week, that which topic shall I take, so you can drop that in the comment section below. Your all suggestions are highly welcome. So that's all for the introductory part. Now in the next part, the solution is there from the quantum mechanics Monday MCQ. Alright guys, so let's discuss the questions which were asked on the channel on during this last Monday on quantum chemistry. Alright, so we'll start from the first question over here, which was actually asked from the Slater's determinant part, and it says that for hydrogen molecule the ground state wave function is, okay, the ground state wave function was given, that is psi12, and that is equals to phi12 and sigma12. Okay, so where phi refers to the space part, so that means this particular part is the spatial part or the space part, and this is going to be the spin part. All right, now it's given that phi12 is equals to phi21. The form of sigma12 would be, so what you can interpret from this particular equation, few things which you should already know and few things which you can interpret. First of all, you should be well aware about this Slater's determinant. Okay, if you don't know about what is Slater's determinant and how to solve questions related to that, do watch my video which I have already posted on YouTube. So I will just add it up over here in the I button. You can just click it over there and watch this video completely on the Slater's determinant. That is going to be a very useful video, and every year whenever Slater determinant question has been asked, it can be easily done from that particular video. So do watch that. So yeah, in that video also, and for those who who already know, a wave function of a particular molecule can be represented in two, it is represented as the product of your space part and the spin part, right? Now among both of them, one has to be symmetrical and other has to be asymmetrical. That means overall wave function has to be asymmetrical. Okay, overall the wave function has to be asymmetrical. So in that case, if one of them is symmetrical, the other one has to be asymmetrical. Now in the question you have to understand this, that why they have given this phi12 is equals to phi21. They have given this to make it sure that what information they want to give is that this phi part, that means the space part, is actually symmetrical. Okay, that means this is a symmetrical part. That means if you just change the values of, like, if you change the space part for the electrons, for the first and second electron, it is not going to make any difference. So it is a symmetrical part. Okay, so that means the spin part has to be asymmetrical. Okay, this part has to be asymmetrical. Okay, that is what you can interpret. Now if this part is asymmetrical, then only whole overall wave function will become asymmetrical. Now among the options, we have to check that which of the spin part is asymmetrical. Now symmetrical and asymmetrical can be understood in the mathematical language very easily, that addition and product, okay, addition and product, both of them represent symmetrical part, whereas difference or the subtraction represent asymmetrical part. Okay, I'm just telling you in a very layman language that how you can understand symmetrical and asymmetrical wave functions. So here if you see, so this is product of two, alpha 1 beta 2, where alpha and beta are two spin states basically. Alpha is given for the positive half spin of the electron, beta is given for the negative half spin. So alpha 1 beta 2 will represent this kind of space. Alpha 2 beta 1 is going to represent this space. Okay, the third one is having negative sign in between, so it's going to be the asymmetrical spin part, and this is going to be your answer. All right, so what and how you have to answer this, that first thing is that overall wave function has to be asymmetrical. In order to make that, one of the part is already given symmetrical in the question. The second part has to be, that means the spin part has to be asymmetrical. Among the options you have to see that which of them represent a asymmetrical spin part. So this is addition, so it is going to be symmetrical spin part. This is product, this is also product, so they all are going to represent a symmetrical spin part. The only asymmetrical spin part is being expressed in option number 3 or option number C. So that's how this has to be answered. Alright, it was pretty simple. Let's go to the next question. Then it says that a particle is constrained in one dimension box of length 2a with potential Vx is equals to infinite. Okay, it has to be infinite, and where x is less than minus a and x is greater than a. So if this is the length, if this is the box, okay, so if this is, let's say, the one dimensional box, so in that particular case your v is equals to infinite in both these cases, and this is minus a and this is a. Okay, so the length of the box becomes 2a. So what they are asking is energy difference between levels n is equals to 3 and n is equals to 2. So this is a very direct and a very easy question basically. It has been asked from this formula, which is the energy of a particle in a one dimensional box. So it is given by n square h square upon 8 ml square, right, where L is the length, n is the energy level in which the electron is. You just have to put the value and then solve. So first what you have to do, you have to put the value of L as 2a, okay, because the length is given 2a, and then you have to put the value of n as 3 first of all, and then you have to put the length to be 2. Okay, so if you put 3, what you are going to get is 9h square divided by 8m and 2a square. Okay, so that is going to be for energy level 3, minus for energy level 2 you are going to put is, because 2 square is 4, so 4h square divided by 8m and 2a square. Okay, so you can take this whole as the LCM. So 9 minus 4 is going to be 5. Okay, so that is going to be 5h square divided by, and 2 square will be 4 and 8 into 4 will be 32 and ma square. So this is going to be your correct answer. So option number D becomes the correct choice for this particular question. Alright, so this is how you have to solve this particular question. Understood? Let's go to the next question then. It says that for the eigenstate of hydrogen atom, which of the following relation between the expectation value of the kinetic energy T and the potential V holds true? Okay, so that's what you have to answer. So to answer this particular question, what you need to know is the Virial theorem. Okay, Virial theorem. Now, according to this Virial theorem, there are three things which you should actually know. The first thing is that your V, that is your potential energy, is actually equal to twice of your total energy. Okay, so the potential energy is twice of your total energy. E is the total energy, V is the potential energy. Your T, that is your kinetic energy, is actually equal to minus E. Okay, that is negative of the total energy. Alright, so what you can write down from both of these things, what you can interpret from both of these things is that you can just substitute its value over here, or E is equals to minus T, so you can just put it over here. So what you will get will be that V is equals to minus 2T, okay, or you can write down the absolute values. Okay, these all have to be the average values of all of them. Okay, so I'm just writing them in this bracket. So what will be the answer then? The answer will be that 2 times of the kinetic energy is equals to negative of your potential energy, that is given in your option number B. So option B is going to be the correct option. Alright, so this was a direct question from your Virial theorem. Alright, let's talk about the other question. It says that one molecular orbital of a polar molecule AB has the form Ca psi A plus Cb psi B, where psi A and psi B are normalized atomic orbitals centered on A and B respectively. The electron is in orbit. Electron in this orbital is found on atom B with a probability of 90%. Okay, neglecting the overlap between psi A and psi B, a possible set of Ca and Cb is. Okay, now this is going to be very interesting. So let's try to answer this up. I'll try to explain this in the next slide. Alright, so to answer this particular question, a few things which are already given to you is that first of all, this is a polar molecule, right? That means this AB molecule can be written in this form. That is, I'm just considering that A is a positive molecule
and B is the negative molecule, because it is also given that the electron on the orbital is found on the atom B with probability of 90%. That means B is being more electronegative. So I'm just considering that, and I'm just trying to make the molecule like this. Okay, so this is going to be our polar molecule. Alright, so since it is given that the wave function is this, that is Ca psi A plus, alright, this is psi A plus Cb psi B, okay, that is the wave function. Alright, now we know that normalization conditions, okay, normalization condition, what does it tells you? It tells you, and it says that psi and psi B are normalized atomic orbitals, right? That means Ca square plus Cb square is going to be equal to 1, alright? Now it's also given that the probability of finding electron on the B atom is 90%. Now Cb square, the coefficient of this atomic orbital of this B, the coefficient of that and square of that tells you about the probability. So what does that mean? It means that Cb square is actually equal to, that is going to be 90% or 90 upon 100. Okay, so that is going to be your Cb square. So what will be the value of Cb then? So yeah, if Cb square is this much, you can put it over here to calculate Ca square. So Ca square will be how much? 1 minus 90 upon 100. Alright, I have just substituted value of Cb square and I have taken it to the other side. So this will become how much? It will become 10 upon 100, or I can write down 0.1 and I can write down this as 0.9, right? So Cb is going to be under root 0.9, and what is going to be the value of Ca? So Ca is going to be under root 0.1. Now if you just calculate this, the under root of 0.1 is going to be 0.333 something, and the under root of 0.9 is going to be 0.95. So if you check upon the options over here, your Ca has a value of 0.32. Okay, the under root of this will be 0.32 actually, and the under root of 0.9 is going to be 0.95 approximately. So these are going to be the correct answers for this particular question. Option number D will be the correct answer for this. Alright, so I hope this is clear to you. Let's go to the next question then. Alright, let's talk about question number 5. It says that the difference in energy levels of n is equals to 2 and n is equals to 1 of a particle in a one-dimension box is 6 unit of the energy. In the same units, what is the difference in the energy level of n is equals to 3 and n is equals to 2 for the above system? So I'll again explain this in the next slide. Alright, so it says that the difference in energy level of n is equals to 2 and n is equals to 1. That means E2 minus E1 in a particle in one-dimensional box is 6 unit of energy. Okay, that is equals to 6. I'm just taking it equal to 6. So let me just put up the values over here. The value of energy for particle in one-dimensional box, we have already done it. So it's n square h square upon 8 ml square. Let me put the values. So for E is equals to 2, the value of n will be 2. So square of n will be 4. So 4h square upon 8 ml square minus the value of n for E is equals to 1 will be 1. So that will be just h square upon 8 ml square, and that is going to be equal to 6. If I subtract it, so I'll be getting 3h square upon 8 ml square, that will be equal to 6. Or I can divide both sides by 3, so I will get h square upon 8 ml square, and that is going to be equal to 2. Okay, so that is what I got from the first condition which is given to me. Now it is said that I have to calculate for n is equals to 3 and n is equals to 2, the difference between them. So E3 minus E2 is what I have to calculate. So let me just put the values. So again, if I put n is equals to 3 here, so it will be 9h square upon 8 ml square minus, if I put 2, so it will be again 4h square upon 8 ml square. Alright, so if I take the LCM and subtract it, so 9 minus 4 will be 5 h square upon 8 ml square. Now you know the value of this part, right? H square upon 8 ml square, it was having value 2. So that will be 5 into 2, and the answer will be 10 units. So the answer of this particular question is going to be 10 units, and that's how it has to be solved. Alright, so I hope this is much clear to you. Now let's go to the next question. Alright, so let's talk about question number 6 over here. It says that the following are the 3 statements about the perturbation theory. Okay, now this question is again from direct perturbation theory and the statements about it, and it says that the statements are as follows, that it says second order perturbation correction to the ground state energy is always negative. Okay, that is the first point. Second says that the sum of sum of the zeroth order of the first order correction to the ground state energy is always greater than that of the exact ground state energy. Alright, so that is the second thing. The third one says that sum of the zeroth order of first order energy correction, sum of the zeroth order and the first order energy correction to the ground state energy level is less than the exact energy. So we have to tell that which statement is correct. Now if you look upon the second order energy correction formula, it is given by En2, that means second order energy correction for the nth energy level, and that is actually given by sigma m should not be equal to n, and it is given by phi m. Alright, then you have whatever you are correcting out, I am just expressing it at, let's say, a. Okay, and then you have phi n, and like the perturbed part, here you have to put the perturbed part, right? And then you have En naught minus Em naught. So that means over here, you know that generally what happens, that your Em naught is actually greater than your En naught. This is zeroth order energy correction in the mth level, zeroth order energy correction in the nth level, and always you know that your m is greater than, like the m is actually greater than n. Okay, so in this particular case, if you put it over here, you will get a negative term. Okay, because you are subtracting a bigger number from the smaller one, so the denominator will always remain negative. So the first statement is correct. Okay, so the second order perturbation correction is always negative. If we talk about the second statement, it says sum of zeroth order and the first order correction to the ground state energy is always greater than the exact ground state energy. Now you have to remember this thing, that the first order energy correction is always a positive number. Okay, first order energy correction, you are going to get a positive number, and if you add that to the zeroth order energy correction, so you are going to get something which will be always greater than the exact ground state energy. So the sum of your zeroth order energy correction plus your first order energy correction, okay, to any state, let's say to any state, okay, we are talking about the ground state, is always greater than the exact energy level or the exact energy ground state energy value. Okay, so second statement is also correct. The third one is exactly opposite of what it is being said in option in the statement number B. So yeah, the answer is actually both statement A and B are true. Alright, so this is going to be the correct answer for this. Okay, fine, let's go to the next question then. It says, in the next question, it says using Hückel molecular orbital approximation, the two roots of the secular equation of ethene are. Okay, so you have to tell about the ethene molecule, which are the two roots of the secular equation for ethene. Now I have made a video on Hückel molecular orbital theory also, how to find out roots of a Hückel of any molecule, whether it is cyclic or acyclic molecule. I request you, if you have not studied this topic yet, and if you are having trouble studying this topic, if you want a shortcut trick to remember all these things, I have made a video on YouTube here. I'll be just adding the link to that in this I button. Okay, just click on that I button and you will get that video. Okay, so there I have explained that how you can find out these roots of the secular equation of the ethene. You don't have to solve and do anything. Okay, you'll just directly get the roots very easily. Alright, so for ethene molecule, if you just watch that video, you'll get to know, and I'll also explain you that how it will be done. So if you will watch that video, you'll get to understand this in more detail, that how to do that. But let me just tell you a direct formula over here which will be used to solve this. For linear molecules, the energy is being calculated, or the roots are being calculated by this particular value, that is K is equals to, it goes like alpha plus 2 beta, and it goes like cos K pi by n plus 1. Okay, so it's n plus 1, where K will have values like 1, 2, 3, 4 and so on. Okay, so if you just substitute it over here, putting the value of K is equals to 1, and n will be the number of carbons over here. So the number of carbons for ethene will be 2, right? So you just put over here the value 2 here. So, and again, when you put K is equals to 2, so you will get two values, and when you will solve that, you will get to know that the answer will be option number C, that is alpha plus beta and alpha minus beta. These are going to be the roots of your ethene molecule. Alright. So I'll recommend you to watch that video, because over there I have explained in more detail. I'm not explaining in that much detail here, right? Alright, let's talk about the next question then. So it says that for hydrogen molecule in the excited state of sigma G1, sigma S1, the spin part of the triplet state with Ms is equals to 0 is proportional to. So if you talk about the hydrogen molecule, there are three possibilities. The first one is that both the electrons are in parallel spin, okay, or both of them are in anti-parallel spin, or first one is in parallel, the other one is in anti-parallel, and the first one can be in anti-parallel and the second one in parallel, okay. So if I talk about this, so it will be plus half and plus half, so the overall ms value over here will come out to be 1. Alright, here it is minus half and minus half, so overall ms value will come out to be minus 1, which is not asked. What they are asking is ms is equals to 0, so that you are going to get in both these cases, okay, in this case also and in this case also. So that means if I talk about that particular part, so how we will write down in the form of secular determinant. So the first electron has a positive spin, so we call it as alpha 1, first electron having alpha spin. The second one has a negative spin, so we call it beta 2, okay. So second electron having negative spin, so alpha 1 beta 2, plus the other state is alpha 2, okay, the second electron having positive spin, and beta 1, that means the first electron having negative spin. So that is how you will express the ms is equals to 0 value. So for this state only, for this arrangement only, you are going to get ms is equals to 0. So if you look upon the option, the only option which contains that is your option number D. So that is going to be the correct answer for this question. Alright, so this is how it has to be done. Let's go to the next question then, and the next one is pretty simple question. It says that the operator, what you have to do, it's a commutation of x and p square, and it has been again being commuted with x, okay. So what will be the answer there is that they are asking, okay. So it is identical with, so with which of these it is going to be identical, that's what you have to answer. Now I'll try to solve this particular question in the next slide. Alright, so to answer this particular question, let me just tell you a few shortcut tricks first of all, okay. So commutation of x and px to the power n can be written down in this way, okay. There is a direct formula of that, that is n I h cross and px to the power n minus 1. That is one of the formula. And again, if you have this, that is x to the power n px, then that commutation of that can be written as n I h cross and x to the power n minus 1. Alright, so whose power is given, that power you have to take as n minus 1. So if I talk about the question which was given as x comma x p x, okay, it's p only, so it's px basically square. So how much you are going to get? So this x will remain as it is, this x px square. For that you just have to use this identity or this particular shortcut trick. You just have to put that, so it will be 2i h cross and it will be px, because px to the power 2 minus 1 is going to give you 1 itself, okay. So that is what you are going to get. So fine, so what you can do now, you can take out this 2i h cross outside, so it will be 2i h cross I'm taking outside. I'll just get x and px. Again you can use the same identity here, the value of n is 1 now, so it will be 2i h cross, and if you solve this, so you will just get I h cross and px to the power 1 minus 1 will be 0, so just this. So what you will get is 2i square h cross square. Now I square you know is minus 1, so you'll get minus 2 h cross square. That is going to be the answer. Okay, now you have to check the options, okay. So you can check out all these options and just try it one by one, but I'll recommend you to solve C and D. That is, these are more prominent and these will be more easier to use these identities and solve them, okay. So if I take option number C and solve, so what I'm going to get actually over here is minus, and this is P, okay. And if I solve this using this identity, so what I will get, so n value is 2, right. So I'm going to get what I'll be getting 2 I h cross and x to the power 2 minus 1, so it will remain 2, like 1 only, okay. So this is what I will get. Now 2 I h cross I will take outside, So minus 2I h cross I'll take outside, I'll get P comma x. Okay, again I have to use the same identity. Okay, so again same identity I have to use, uh, or P comma x. Okay, so what you have to use over here, how you can do that? So you just have to use this value. So let me just do it. So you are going to get, okay, so if x comma px is ih cross, what will be p comma x? Okay, so that is going to be minus ih cross. Okay, the value of this is going to be, the commutation of px comma x will be minus ih cross. So minus 2 ih cross, the value of this will be minus ih cross. If you solve this, so minus minus will get cancelled out, you will get 2 I square h cross square. Okay, I square will be minus 1, so 2h cross is minus 2h cross square will be the answer. So like that you have to use. So two things I have done. I have used this identity to find out this. Then px comma x, I have written it like this. Remember what I have done? I have used this, that is x px is ih cross, and this px comma x which I got over here was actually equal to minus ih cross. Okay, so this is how we have done this, and that's how it has to be solved. It's just based upon commutation. Few basic formula, few direct formulas are there which you should know in order to make the solution very simple and easy. Let's go to the next question then. Alright, let's talk about question number 10 now. It says for a particle in a box problem in 0L, that means the length of the box is L and it starts from 0 and ends to L. The value of x cube, okay, so you have to tell the value of x cube in the n it turns to infinity limit would be. So let's try to solve it in the next slide. So how we are going to solve this? First of all, we'll start it from the integral, and we are doing it from 0 to L, and it is, let's say the wave function is psi, so psi x cube and psi d tau. Okay, this is psi star d tau. So that's what that's how we are going to solve it, right? Because we have to find out the value of like mod x, like average value of x cube. So let's put the value of the wave function now, psi, for the particle in a one dimension box. So it will be 0 to L, particle in one dimension box, the psi value or the wave function is given by under root 2 by L sine n pi x by L. Okay, so that's what you will get, into x square into, it will be under root 2 by L and sine n pi x by L. Alright, so that's what you are going to get. You just can multiply this term and this term, because psi and psi star are same, so you can just multiply both of them. So you'll get from 0 to 0 to L, and it will be 2 by L sine square n pi x by L, and this is x cube, not x square, right? So you can take out this x, yeah, so you can just write down here x cube also. Okay, so I've just written all the terms. Now you should know one thing, that sine square theta, okay, sine square theta is actually equal to 1 minus cos 2 theta divided by 2. Okay, so what I can do now, I can just substitute it over here. So what I will get is, first of all, 2 by L I can take out from the integral. So 2 by L will be taken outside because that's a constant term. So 0 to L, and it will be x cube, and it will be 1 minus cos 2 theta. So 2 theta means 2 pi, 2 n pi, right? N is also there. So 2 n pi x by L. Okay, that's what I will get, and divided by 2 and dx. Okay, it will be dx. That's what I was missing till now. So dx would be there. Now you can just separately divide it. You can just multiply with x cube inside, and you can just separately divide that. So it will be 2 by L integral from 0 to L, and it will be x cube by 2. Okay, that will be the first term of the integral. Okay, and minus this will be also multiplied inside. So 1 by 2 you can take outside, and integral of from 0 to L, and this is going to be x cube and cos 2 n pi x by L. Okay, and dx. Okay, remember that for any trigonometric function, either it is cos or sine, your 2 and pi, okay, when you do it for overall one complete cycle, for that the value will be equal to 0. So this particular part will be actually equal to 0. So this will get vanished. So this part is will you will not get anything over here. You just have to integrate what? You just have to integrate x cube. So integral of x cube will be x to the power 4 upon 4. So what you will get is 2 upon L and integral of and into this 1 upon 2 also. So I am just taking out this 1 upon 2. X cube will get integrated and it will be x to the power 4 upon 4 and it will be from 0 to L. Alright. So this 2 is going to cancel out this cube, this 2, and now you are going to get 1 by L and you just have to substitute the upper limit. Upper limit will be L, so L to the power 4 divided by 4 and minus 0. Lower limit will be 0, right? So you can just take it outside. So this L is going to cancel out one of the L. The answer will come out to be L cube upon 4. Okay, so the correct answer is going to be L cube upon 4. So that is how it has to be solved, and the correct answer comes out to be your option number C. Alright. So there was a lot of calculus involved. For bio student it might be little bit difficult, but for math student this should not be difficult question. Okay, it's a very simple one. Alright, let's go to the last question then. Okay, let's talk about the last question. It says identify the Hückel determinant for cyclobutadiene. Okay, you have to talk about cyclobutadiene. There are 4 determinants made from the Hückel molecular orbital theory. You have to tell which of these belongs to cyclobutadiene. So I'll try to explain to you this particular thing in the next slide. Alright. So when we talk about cyclobutadiene, it will look something like this. Let me label up the the carbon. So it will be 1, 2, 3 and 4. That is how it is going to be labeled up. And if you make the determinant, the secular determinant of that, so what you are going to get will be H11 minus ES11, then H12 minus ES12, then H13 minus ES13, then H14 minus ES14, and it will go something like that itself, right? Alright, so this is going to be the determinant which you are going to form. Now, once you have done with this, few values which you already know. The values are like H11 will be equal to H22, will be equal to H33, will be equal to H44, and these are going to be equal to alpha. Okay, these are called as the Coulomb integrals, right? So these are Coulomb integrals. Then the next thing is that you have these values, that is H12, that will be equal to H21. Okay, H21 is equals to H14 is equals to H41 is equals to H23 is equals to H32, and that will be equal to H34, and that will be equal to H43. That means first of all we have separated out all those where the value of I and j is same. They are going to be alpha. For them whose I and j are different, they are going to be called as beta. Okay, and these are called as the exchange integrals. Okay, so exchange integrals. Alright, now one more thing which we know is that if Sij we have, if I is equals to j, it has a value of 1, right? And if I is not equal to j, in that case it has a value of 0. So that means S11 will be 1, but S12, S13, S14, they all are going to be 0. Okay. Similarly, S22 is going to be 1, the other one all in this particular row is going to be 0. S33 is going to be 1, other 3 are going to be 0. This is going to be 1. Okay. So let me just put all the values which we have just done and make the determinant, and that is going to be the final answer. So the final determinant will be alpha minus E, because the value of S11 is going to be 1. Here this particular part will become 0 and H12 will be equal to beta, so we'll just get beta here. again over here if you see, so in this particular case H13 where right, so you have H13, right? Yeah, one more thing that if the difference over here just like it's 1 2 2 1, okay, 1 4 4 1, then you have 2 3 and 3 2, and you have 3 4 and 4 3, the one which are just adjacent to each other, 1 2, okay. Then there is a bond between 2 3, so that's why 2 3 is taken, 3 2 is also taken, then 3 4, the bond is between 3 4 and 4 3, so that's why they all are equal to beta, but there is no bond between 1 and 3, so that we have not discussed. So that means H13, okay, there is no bond between 1 and 3, right, in the atom, in the molecule basically. And similarly there is no bond between 3 and 1. Similarly between 2 and 4 there is no bond, so they are going to be equal to 0. Similarly H24 and H42, they are going to be 0, okay. So remember this, why they are 0, because there is no bonding between these particular atoms, okay. So fine, so that means H13 wala part will become 0, this part is obviously 0 because of the value of S, so overall it is going to become 0. The last part H14 is going to be beta, and the other part will be 0, so only beta will be here. In the next column we will be having beta from here, because this is actually equal to beta, and this particular part will be 0. Here you will get alpha minus E, then you will have beta from here H23, so you get beta, and the last one will be 0 because there is no bond between 2 and 4. So in the same way, just by substituting all of them, you will form the whole determinant like this. So the determinant will be 0 beta, then you have alpha minus E, then you have beta, then you have beta 0, then you have beta and alpha minus E. So that is how you are going to form the final determinant, and that is going to be the, like, that's how you will just do this, okay. So if you look upon the question which is given over here, and if you match whatever we have just done, if you match that with the question, so you are going to get option number C as the correct option. So that's how these questions were being done. We have taken 11 questions in this particular week from the quantum chemistry, and I hope you guys like this, I hope you guys understood it well. And that's all for this particular video, guys. If you are new to this channel, do subscribe to the channel. If you like this video, give it a like. If you want to ask anything, you can ask that in the comment section below. If you want to give any suggestion, that those are always welcome. So thank you so much for watching the video, and have a great day.